being given by Tobias Grosse-Puppendahl, and he's talking about exploring the design space for energy harvesting situated displays.
Thank you very much. So nowadays, displays are pretty much everywhere. We can buy them in retail stores, and we even often have multiple displays within a room. And it seems that digital information displays have become ubiquitous, but unfortunately not in all areas of our lives. So, for example, we live in a world in which most displays consume a lot of power, and many of them are emissive, and we often turn them off if they are not needed. And this is actually wasting a lot of space when we think about our living room, for example. Also, we need to wire them up, and that often prevents us from deploying them in many places, for example, on a bathroom window or somewhere outdoors. And especially due to the high amount of instrumentation needed here, we cannot install displays in arbitrary locations, and we have reached a point of saturation with conventional displays. So, at the same time, we can observe a need for information visualization in contextual locations, as described in the work by Elliot and others, shown here. And we see that people use Postit Notes in such places which are inaccessible for traditional displays. But unfortunately, these physical nodes cannot make use of a digital information infrastructure, like being updated automatically or being able to expire. And to approach this, researchers have built many forms of situated displays, such as this gate reminder shown on the top, or resource monitors here shown on the bottom right. So, assuming we are surrounded by such situated displays, and they would replace all the information pieces around us, we will still need to find means to power them, for example, by batteries. And if you own just a single display, it's really not a problem to charge a battery once a year. But imagine you had 20 or 30 displays, which is very likely. We definitely need energy harvesting operation. And there have been a few works on energy harvesting combined with displays regarding different use cases. For example, as a mobile phone companion display powered by NFC using e-paper as display technology, or as a variable camera using solar and then being able to visualize an image on the e-paper screen. Other products, like this Toshiba e-reader, which is solar-powered, have never made it to market. So when we design an energy-neutral situated display, we essentially approach three technological challenges or design dimensions. First is energy harvesting, second is display technology, and third is the choice of communication. So to build our proof of concept device, which I will introduce in the following, we analyzed a number of different choices we had regarding these technologies. And we chose to use ambient light due to the relatively high energy density and no external infrastructure required. In terms of display technology, we're using e-paper because it is a bistable technology and it does not need any power to retain its display state. And this makes it very low power. For communication, we use Bluetooth Low Energy, which is very low power compared to Wi-Fi, for example, and is also compatible with most consumer devices which we use right now, like smartphones. And based on these design dimensions, we built a small sticker-like display that can be deployed at different locations to show contextual information, such as the weather forecast, information about the daily commute, or the number of unread chat messages. So the display uses a solar panel on the back, which tops up a thin film battery, and the rear of the PCB consists of pixel drivers, which you can see here, Bluetooth Low Energy communication, and an energy harvesting part. On the top of the PCB, we have the pixel electrodes, and to these electrodes, a sheet of e-paper is bonded. So we built two prototypes, one with a low-resolution pixel grid, which you can see on the top, and one as a segmented display. The hardware architecture between those two doesn't differ a lot, just in terms of the display driver, which I will talk about later. So we basically have an energy harvesting part, which is shown here in blue, which consumes a very tiny amount of energy and which triggers a wake-up of the Bluetooth Low Energy module. And then, if enough energy is available, we initiate communications and drive a display update. This is the low-resolution pixel grid we're using. To realize this, we used a shift register with 132 binary pixels that drive the e-paper media. And the segmented display only consists of 24 segments, which are driven directly by a port expander. So why did we not use a high-resolution display? Essentially, it comes down to energy consumption. And compared to related work, we use relatively few pixels which are visible at a distance and which are suitable for this use case of situated displays. And by reducing the number of pixels while maintaining the physical display size, we achieve up to 35 times less energy consumption of our pixel display compared to even smaller high-resolution displays. So in our system, a display update only requires a small percentage of the total energy needed to run the overall system, which is currently dominated by Bluetooth communications instead of by the display update. So it would not have been possible to design a system with a similar update rate using a conventional high-resolution display. In terms of update rate, we achieve a relatively high number of updates when the display is attached to a window with access to ambient sunlight. Updates can be run every couple of minutes when using the display indoors, such as attached to an indoor window as this glass door, or on an office desk, while fewer updates can be run in shady places, like when it's attached to this PC monitor here, which decreases the update rate to 25 minutes. So as future work, we see many challenges arising when managing a multitude of slowly updating displays, and we imagine that augmented reality could be a great way to approach this problem, to make use of the spatial relationships between multiple displays, and also show other contextual information. Thank you very much.
Last chance to ask a question. Anyone? No? Okay. So I was wondering, when we build hardware, we always see how everything is shiny and beautiful in the end and it works. I was wondering, can you share some hardware building experiences? Did you try some materials which didn't work? How about like scaling down, scaling up, and these things?
Yeah, this is a very good question. And I think handling e-paper is a very interesting experience, since we were not using like ready-made displays, but we created the display on our own by basically bonding the e-paper with a t-shirt press onto the display. So the manufacturer basically told us use like 55 psi and 120 degrees, and we thought, hey, how can we do this? We had a t-shirt press and basically bonded these displays, and it was quite hard to achieve a good quality. And sometimes you can actually see that there are sort of some spots here and there which are not perfect yet, and it took a while to get to that point. Yeah.
Any other question? Everybody wants to go to lunch. All right, then let's thank all the speakers again, and this basically concludes the session.